In the previous class, we already learned what is queue, how queue works. We already learned how many types of queue, that is linear queue, circular queue, DEQUE, priority queue. We already learned how linear queue and circular queue works. What is the corresponding programming? What is the logic? We already learned this thing. Today our topic is number 3, that is DEQUE or double-ended queue. So what is DEQUE? A DEQUE is a linear list in which elements can be added or removed at either end but not in the middle. So it is a linear list and we can add element or delete element from the left side of the queue. We can add element or delete element from the right side of the queue but not from the middle of the queue. We will assume that our queue is maintained by a circular array. DEQUE is also a circular queue with pointers left and right. There are two pointers, left pointer and right pointer, which points to the left end and right end of the queue. So there are two pointers, left pointer points to the left end of the queue and right pointer points to the right end of the queue. Now see how DEQUE works. See, this is our DEQUE. There are 6 memories from 0 to 5. So total 6 memories. So what is left pointer and what is right pointer? What is the value of left and value of right? Left is 1 and right is 3. Left 1, right 3. Now case 1. Insert F at the right end. So F, you have to insert F, the alphabet F at the right end. Right is 3. So after insertion, F will be here. So what is the value of right? It is 4. Now case 2. Two letters on the right are deleted. So two letters from the right are deleted. So you have to delete F and D from the right. So what is the value of right now? It is 2. Case 3. K, L and M are added to the left of the DEQUE. I already told that DEQUE is the circular queue. So when you want to add K, L and M, first K is here. See, K is here. Because DEQUE is a circular queue, so L will be added. It may imagine that it is circular. So L will be added here and M is added here. So L and M. Now tell me, what is the value of left and right? Because here we are using left pointer only. So the value of left is 4 now. Right, it's still 2. Case number 4. One letter on the left is deleted. So from the left you have to delete one letter. So what is the value of left? It is 4. After deletion, you have to delete M. What is the value of left now? It is 5. Now case 5. R is added to the left of the DEQUE. So R is added to the left of the DEQUE means left is 5. So when you want to add R, R is here. So what is the value of left now? Left is 4 again. Case 6. Insert S at the right end. Right is 2. When we want to insert S, so S is here. So S is here. Now right is 3. So the conclusion is, I have some question, you have to answer that. Now the question comes, if an element is added on the left, left is decreased by 1 or increased by 1. Yes, if an element is added on the left, left is decreased by 1. Now, if an element is added on the right, right is increased by 1 or decreased by 1. Yes, if an element is added on the right, right is increased by 1. Question number 3. If an element is deleted from the left, left is decreased by 1 or increased by 1? Answer is, if an element is deleted from the left, left is increased by 1. Question number 4. If an element is deleted from the right, right is decreased by 1 or increased by 1? Answer is, if an element is deleted from the right, right is decreased by 1. Now, if before deletion it is found that left and right are equal, then we can say that there is one single element on the DQ. Then after deletion, make both left and right as -1, which indicate that our DQ is empty. I repeat, when there is a single element in the queue. How we can found that there is a single element in the queue? When the value of left and right are equal, we can say that there is a single element in the queue. So after deletion, your queue becomes empty. When your queue is empty, you have to make left and right value as -1. So what is the initializing condition? Initializing condition is both the value of left and right are -1. The DQ will be empty when the value of left and right are -1. The DQ will be full if the difference of left and right be 1. So the difference of left and right 1 means there is no gap, then we can say that our DQ is full. Or when left is 0 means it is extreme left and right is max -1 means it is extreme right, then we can say that our DQ is full. What is the data structure of DQ? Data structure of DQ is, first you have to write that keyword struct. Our structure name is DQ. There is one integer array item. Say max is the maximum number of element that our queue can hold. And there are two integer variable, left and right. Both are integer variable. This is the data structure of DQ. And struct DQ Q is the object of this structure. Now what are the operations? Operations of DQ are number 1 empty to check whether our DQ is empty or not. Full to check whether our DQ is full or not. Remove left means I want to remove element from the left hand side, from the left pointer. Remove right, I want to remove from the right. Insert left, I want to insert a new element in the left side. Insert right, I want to insert any new element in the right side. So these are the primitive operations of DQ. Now function empty. This function returns 1 or 0. If the queue is empty, it returns 1. If the queue is not empty, it returns 0. So it returns either 1 or 0. Both are integers, so the return type is integer. Function name is empty. Here we are passing the address of this DQ. So you have to write struct DQ star Q, means Q can hold address of the queue structure. Now when our queue is empty, then both the value of left and right are -1. So you have to check whether the value of left and right both are -1 or not. So you have to give here AND condition. Both are -1, then our queue is empty, return 1, otherwise return 0. Now see, this left and right both are the variable of the queue structure, this DQ structure. So to access this variable, you have to use either object or the address. Here we are passing the address of this queue structure. So to access this element left and right, you have to use arrow operator. So you have to write q arrow left and q arrow right is r -1. Both are -1, then our queue is empty, return 1, otherwise return 0. Now your task is to try to write full function by your own. Now function full. If our DQ is full, then this function returns 1, otherwise this function returns 0. So it returns either 1 or 0, both are integer, so return type is integer. Function name is full. Here we are passing the address of the queue structure. So this DQ structure we are passing. So you have to write struct DQ star queue. So queue can hold the base address of the queue structure. Now see what is the condition for full. See condition for full. See when the queue is empty, value of left is -1 and value of right is -1. Now I want to insert one element in the queue, say A. So left is 0, value of left is 0 and right is 0 because it is a single element on the queue. So both left and right both are 0. Now I want to insert B at the right end. So B is here, right value is 1. Now want to insert C at the right end. C is here, right value is 2. Want to insert D at the right end, right value is 3. Want to insert E at the right end, so the right value is 4. And want to insert F at the right end, so the right value is 5. Now, what is the value of max? Means how many number of elements are there in the queue? It is 6. So max is 6. So what is the condition for full? When the left pointer value is 0 and right pointer value is max -1, we can say that our queue is full. When left is 0 and right is max -1, we can say our queue is full. This is one condition. Another situation is say like this. There are two elements in the queue, B and C. So what is the value of left? It is 1. What is the value of right? It is 2. In this situation, I want to insert at the left. Say I want to insert A at the left. What is the value of A? It is 0. I want to insert D at the left because DQ is circular. So insert D at the left means start inserting from here. So D at the left. So D is here and left is 5. I want to insert E at the left. So E is here, left is 4. I want to insert F at the left. F is here, left is 3. Now the queue is full. See, the difference between left and right is left minus right is 1. So what is the another condition of full? Another condition of full is when the difference between left minus right is 1, then we can say our queue is full. Take another situation. See, the situation is like this. Left is 2, there is 2 elements, left is 2 and right is 3. This is situation, only C and F are there. Now I want to insert at the right end. Say I want to insert E at the right end. So right is 4. I want to insert G at the right end. So right is 5. I want to insert K at the right end. Because it is circular, start insertion from the beginning. So K is here. Right value is 0 now. I want to insert L at the right end. So L is here, right value is 1 now. So what is the difference between left and right? It is 1. So queue is full. So there are two conditions. When the difference between left and right is 1 or left is 0 and right is max -1. Now see, either this condition is true or this condition is true. Either the difference between left minus right is 1 or left is 0, right is max -1. Now think why we are using or here and why we are using and here. Or means either this condition is true or this condition is true. And means in this case when left is 0 and also right is max -1, both conditions should be true. Okay, so this is the condition for full. So the coding. Here if left minus right is equals to 1 or left equals to 0 and right equals to max minus 1, then only we can say the queue is full, return 1, otherwise return 0. Now see, left, right, all are the elements or all are the variables of this DQ structure. To access these variables, you have to use arrow operator, because we are passing the address of the DQ structure. So you have to write q arrow left minus q arrow right equals to 1 or q arrow left equals to 0 and q arrow right equals to max minus 1. Next we will learn insert left function. Means we want to insert a new element by the left pointer to the DQ. Now we will learn insert left function. Insert left means I want to insert by the left pointer a new element to the DQ. So here the function name is insert left. Here I am passing the address of this DQ structure and the element which I want to insert. Say the element is X. Now before insertion you have to check whether your queue is already full or not. So call the full function by passing the address of the queue structure. See, this is our full function. We already learned how to write full function and how to pass the address. See here, we are passing the address of the queue structure. Now, if this function returns 1, means our queue is full, then it is impossible to insert. Otherwise, you can insert. So, first check if call the function full. If that function returns 1, then it is impossible to insert. Otherwise, you have to insert. Now, see the calculation. See, first check whether our queue is full or not. If full, then it is impossible. Otherwise, you have to check your queue is empty or not. If your queue is empty, then you have to start insertion. Okay. And when you insert one element, then make both left and right as 0. Means say I want to insert A here. Okay. See, before that, when our queue is empty, value of left is minus 1 and right is also minus 1. Okay. Now I want to insert A here by the left pointer. So A is here. When A is here, both left is 0. Also, right is 0 because there is a single element in the queue. So, when q arrow left is minus 1, then we can say our queue is empty. When you start your insertion, then make both left and right as 0. Okay. Otherwise, in this case, say when there is one normal case, say it is A, it is B, it is C. So, what is the value of left pointer? It is 3. What is the value of right pointer? It is 5. In this situation, I want to insert one new value to the left, say D. I want to insert D here. So, when it is D, what is the value of left pointer? It decreased. Again, I want to insert at left. So, when it is E, then left pointer decreased. When it is say F, I want to insert at the left F, then it is decreased. So, always left pointer decreased for insertion. So, see here q arrow left minus minus. Now, when it is 0, this situation when it is 0, now I want to insert G at the left. Then it start insertion from the 9th position. So, when it is 0, then if you want to insert G here, left, at the left you want to insert G. So, it is circular. So, start insertion from here. So, G. So, what is the value of left now? It is 9. So, the logic is if q arrow left is 0, then q arrow left is max minus 1. Otherwise, now I want to insert H here, H at the left. So, H is here. Otherwise, the pointer decreased. So, see the total code. First is when q arrow left is minus 1, means if the queue is empty. Then when you start insertion, then make both left and right as 0. because there is single element. Otherwise, if q arrow left is 0, then q arrow left is max minus 1. Otherwise, you have to decrease left pointer. So, decrease left pointer, decrease left pointer. In this way, when it is 0, it is max minus 1. Now, you have to insert that element which you want to insert. Say our element is here, it is x. You want to insert. Where you have to insert? You have to insert at that location where left point. So, see in this case when I want to insert h at location where? Item 8. You have to write item 8 is h. Is h. You can also write 8 means what? 8 means our left pointer. You can also write item left. Left is h. H is what? H is our x variable. So x. So item left is equal to x. Now item left are the variable of the queue structure. So to access this variable, you have to use arrow operator because we are passing here the address of the queue structure. So you have to write q arrow item q arrow left is x. So this is the coding. So the coding is first you have to check whether your queue is full or not. If full, then it is impossible. Otherwise, if your queue is empty, start insertion from the beginning. Make both left and right as 0 because there is single element. Now, if left is 0, then after insertion means when the value of left is 0, then next you have to insert at max minus 1. So if q arrow left is 0, then q arrow left is max minus 1. Otherwise, you have to decrease left and insert that particular element which you want to insert to that location where left points. So this is the coding for insert left function. Now your task is to try to write insertright function by your own. Make slight modification of the insertleft function. Think and try to write insertright function by your own. Now the insertright function. Here I am sending the address of the DEQUE structure and the element which I want to insert. Say it is x. Now also here also we have to check whether our queue is already full or not. If our queue is already full, then it is impossible to insert at the right. Okay, so call the function full. We already learned how to write full function, and if that function returns 1, means if this function returns 1, then our queue is full. Then there is one printf statement. It is impossible to insert any new element in the queue. Otherwise, you can insert. Now see how we can change the insert left function to make it insert right function. See. So this is our insert left function. We have to change this function as insert right function. So the function name is insert right. Here also we are sending the address of the DEQUE and the value which I want to insert. Now check whether our queue is already full or not. If it is already full, then it is impossible to insert. Otherwise, if the queue is empty, if the queue is empty means what is the left pointer value? It is minus 1. What is the right pointer value? It is minus 1. So, if because we are inserting at the right, so we are checking the right pointer. If the right pointer value is minus 1, we can say that our queue is empty. Then when I insert a new element in this queue, say I want to insert a new element in the queue. So insert a here. So make both left and right pointer as max minus 1. Because it is insert right function. So make both left and right as max minus 1. So this is one case. Another case is if say this is the situation. If the left pointer value is say 3 and right pointer value is say 5. Left is 3, right is 5. I want to insert D at right. So insert D here. So right pointer value is 6. Then I want to insert E at right. So E here, right pointer value is 7. Want to insert F at the right, F here. So right pointer value is 8. So always increase right pointer when you want to insert a new element to the right. So Q arrow right plus plus. Always you have to increase right pointer. Now I want to insert G at right. So G is here. So it is 9. Now when right is max minus 1, then start inserting from the 0th element because DQ is circular queue. So if right value is max minus 1, if right value is max minus 1, then start inserting from the 0th element. So it is 0. Now insert your element, the element which you want to insert at the right. So this is the coding for insertright. So first check whether full or not. If full, then it is impossible to insert. Otherwise, if the Q arrow right is -1, then insert first element and make both left and right as max -1. Now, if the right pointer is max -1, then start inserting from the beginning. So then if Q arrow right is max -1, then Q arrow right is 0. Otherwise, you have to increase right pointer. Now, you want to insert this element x where right points. So item right is x. See the code. So this is our insertright function. We are sending the address of the queue and the value which you want to insert. Check whether queue is full or not. If full, then it is impossible to insert. Now check your queue is empty or not. If the right pointer is -1, then we can say our queue is empty. Then start insertion from the rightmost element. So make Q arrow right and Q arrow left both max -1. Now, if Q arrow right is max -1, start insertion from the beginning of the queue, then make Q arrow right is 0. Otherwise, you have to increase Q arrow right and then insert the value x where right pointer points. So, item right equals to x. Now, see item right left all are the variable of this DQ structure. So, to access this element, you have to use arrow operator because we are passing the address of the DQ structure. Now, remove left function. So, function remove left. Here also, we are passing the address of this DQ structure and the element which is removed will be removed and return to the main from where this remove left function is called. Because our DQ is say it is a integer queue, so return type is integer. Because all the element in this DQ are integer elements, so the return type is integer. Here also we have to call the empty function. We learned how to write empty function. So call the empty function. If that function returns 1, means our queue is empty, otherwise not. So if it is empty, then it is impossible to remove further any new element from the queue. So we are passing the address of this queue structure. See here we are passing the address of the queue structure, and if this function returns 1, then it is impossible to remove. Otherwise, see function remove left. Here we pass the address of the DQ structure. Now the removed element should be returned. Say our DQ is an integer queue. So all elements within this DQ are integer. So when we delete the element, the returned element is also integer. See here, int x, and I return x. So the return type is integer. Now check if our queue is empty or not. If our queue is empty, then it is impossible to delete any new element from the queue. Otherwise, you have to remove. So call the function empty. If that function returns 1, then our queue is empty, then it is impossible to remove any element from the queue. Else, if the situation is like this, there are 3 elements in our DEQUE. So left is 4, right is 6. Now I want to remove from the left. So I can write x equals to 11 and I have to return this x. I can also write in this way, x is what? X is item 4. So x is item 4. So x is small x. X is item 4. Okay. And item 4 means what? Left is 4. So I can also write x equals to item left. So then return x. So q arrow item, q arrow left, because item left are the variables of the queue structure, this DEQUE structure. So you have to use arrow operator. So q arrow item, q arrow left is stored in the variable x and you have to return x. Now if the situation is like this, it is 11, say it is 22, it is 33. What is the value of left? Left is what? 3 and right is what? 5. Now I want to delete from the left. So delete 11. What is the value of left now? 4. Again delete from left. Delete 22. What is the value of left now? It is 5. So always you have to increase left. So you have to write q arrow left plus plus. After deletion, you have to increase left. Now if this is the situation when there is a single element, means left and right both are 5, means both are same. So how we can check there is a single element or not? When the value of left and right are same. So when the value of left and right are same, we can say there is a single element. Now, after deletion, your queue becomes empty. When the queue is empty, what is the condition for queue empty? Queue empty condition is make both left and right as -1. So you have to make both left pointer and right pointer as -1. So if q arrow left equals to q arrow right is equals to q arrow right, means there is a single element, then make both left and right as -1, that is empty condition. Okay. So this is the case of single element. Otherwise you have to increase left. After deletion you have to increase left. Now another condition. Another condition is like this. If say your queue is like this, these are elements are there in the queue. Okay. These elements are there. So what is the value of left? Left is 8. And what is the value of right? Right is say 1. Now I want to delete from the left. So delete left, delete 11. What is the value of left now? It is 9. As usual, it will increase. Now after deletion of 9, because DEQUE is circular, you have to start deletion from the 0th element. So when value of left is max -1, that is 9, then you have to start from 0th element. So this is that condition. When value of left is max -1, then q arrow left is 0. So when it is 22, when I want to delete 22, then left becomes 0. So if value of left is max -1, then left becomes 0. Otherwise, say delete 33 from the left. Otherwise, left will increase. So left is 1 in this way. So see the total code. The code is like this. Because it is integer q, we remove the element and return that element from where this function is called. Because all elements are integers, so the removed element is also integer, so the return type is integer. Function name is removeleft. We are passing the address of this DEQUE structure. Now call the function empty. We already learned how to write empty function. If that function returns 1, means our DEQUE is empty, then it is impossible to delete, otherwise you can delete. Here we are passing the address of the DEQUE. See here, we are passing the address of the DEQUE. Okay. Else you have to remove the element. So first take the element pointed by the left pointer, store it to the variable x and return that variable. Means that element you have to take which is pointed by the left pointer and store it to the variable x and return x. Otherwise, if the case comes that there is a single element, how we can check there is a single element? When the value of left and right pointer are same, means there is a single element. So after deletion your queue becomes empty, so make both left and right as -1. Otherwise, if the value of q arrow left is max -1, because DEQUE is a circular queue, start deleting from the 0th element. So if q arrow left is max -1, then q arrow left is 0. Otherwise, you have to increase the left pointer after deletion. So this is the total code for removeleft function. Now your task is to change the coding of removeleft function to make it removeриght function. Try to write removeриght function by your own. Now see how we can change the removeleft function to make it removeright function. Okay. So this is our removeleft function. Coding for removeleft function, I make it removeright. So function name is removeright. Here also we are passing the address of the DEQUE structure, and the element which is removed is integer element because our queue is an integer queue. So the removed element is also integer. Now check whether our queue is already empty or not. If it is already empty, then it is impossible to remove further any new element from the DEQUE. Otherwise you can remove. Otherwise you have to take that element which is pointed by the remove by the right pointer, because our function name is removeright and we want to remove from the right. So q arrow item q arrow right will be stored in the variable x. I declare variable x here and return the variable. Now this case is also same like removeleft function. If there is a single element, means value of left pointer and right pointer are same, then after removal make both left and right as -1 because your queue is now empty. So make both left and right as -1. Take another situation. Say the values are 11, 22, 33, 44 and 55. Okay. So what is the value of left pointer and what is the value of right pointer? Left pointer is say 8 and right pointer is say 2. Now I want to remove from the right. So first remove 11. So right pointer decreased. So right becomes 1. Again remove 22 from the right. Right pointer decreased. Right becomes 0. So always after removal, right pointer decrease. So you have to write here right minus minus. Now after that, if I want to remove from the right 33. Now if it is 0, then because DEQUE is a circular queue, start removing from max -1. So if right pointer is 0, then right pointer becomes max -1. So you have to write in this way: if right is 0, then right is max -1. right is max minus 1. So this is another case. So see the total coding. So the coding is, first function name is removeRight. We are passing the address of this DEQUE structure, and the element which I want to remove is an integer element because it is an integer queue. So call the function empty. We already learned how to write empty function. If that function returns 1, then we can say that our queue is empty, it is impossible to remove. Otherwise, you can remove. Here we are passing the address of the DEQUE structure. See, now you have to remove that element which is pointed by the right pointer. So take the element item right and store it to the variable x and return x. Now, if there is a single element, how we can check there is a single element? If the value of left and right pointer are same, then we can say that there is a single element. So after removal, your queue becomes empty. So make both left and right as -1. Otherwise, if the right pointer value is 0, because the queue is a circular queue, start removal from the max -1. If right is 0, then right becomes max -1. Otherwise, right pointer decreased. So this is the code for removeRight function. Now see the programming for DEQUE. So see this code. Here the queue size is max, that is 6. We define one macro, has defined max 6. These are the all 6 function, that is empty function, full function, remove left function, insert left function, remove right function, insert right functions. Prototypes are here. Now this is the queue structure, our DEQUE structure. This is item max, this is left pointer, right pointer, and this is the object of the queue structure. Now you have to initialize in main both left and right as -1 because our queue is empty. Now the index. We start one do while loop. Take the choice from the user. Supply your choice. First choice is left insertion. Second choice is left removal. Third choice is right insertion. Fourth choice is right removal. Fifth is exit, means close the program. Sixth is default, that is wrong key. Now take the choice. Here we are using a switch case control statement. Switch choice. Case 1 is you want to insert in the left. So supply the element from the left insertion, take that element and call the function insertleft by passing the address of the queue and the value which you want to insert. Case 2, remove left. Call the function removeleft by passing the address of the queue, and that function returns the deleted element, and here we are printing the left removed element. So it is y. Now case 3 is supply the element for the right insertion. Take the element for right insertion, it is x. Now call the function insertright by passing the address of the queue and the value which you want to insert. Okay, and same way removeRight function, case 4, you want to remove from the right. So pass the address of the queue and removed element is stored in the variable y and print the variable y. Case 5 is exit and default case is wrong key. Now this is a do while, it is a infinite loop, do, here do, and this is while. So this is an infinite loop. So to come out from the loop you have to use case 5. Okay, and these are the function we already discussed each and every detail of this function. So this is empty function, this is full function, this is insert left function, and this is remove left function. This is insert right function and this is remove right function. Now when we run the program, see, supply your choice. Say I want to make left insert. Okay, so case 1, it is, I want to supply the element for left insertion 11. Now I want to make left insertion, so 1, it is 22. Again I want to make left insertion 1, it is 33. Again I want to make left insertion 1, it is 44. Now I want to remove from the left, case 2. So which element will be removed? It is 44. So case 2. So the removed element is 44. Now I want to remove from the right. So the removed element is first element. It is 11. So case 4. So the removed element is 11. Now I want to insert in the right. Okay. So case 3. I want to insert say 10. Okay. Again I want to remove from the right. So 10 will be removed. So 10 will be removed. And case 7, it is wrong key, and case 5, close the program. So I am showing the total code. See, just pause this video, try to do this program by your own. See, these are the header file, inclusion, this is macro, these are the prototype of your functions. Now this is DEQUE structure. This is main function, initialize left and right pointer as -1 for empty queue. This is our index, do while loop. This is our index, take the choice from the user. This is switch case control statement. All cases are written here. Close main, infinite while loop and do while loop and get CG, and then this is empty function, this total empty function, this total full function, this is insert left function, insert left function, then removed left function, then insert right function, remove right function, now you have to do this program by your own. Variations of DEQUE. There are mainly two types of DEQUE. First is input restricted DEQUE, second is output restricted DEQUE. In case of input restricted DEQUE, allows insertion at only one end of the list but allows deletion at both ends of the list. In case of output restricted DEQUE, allows deletion at only one end of the list but allows insertion at both ends of the list. So this is your programming assignment. Write a program to implement primitive operations of DEQUE. Try to answer this question. Choose the correct option and answer me in the comment section what is the correct option. I am waiting for your reply. For getting more and more updates, please subscribe my channel. That's all for today. Thank you.